Hello, good morning all. This is Dr. Abdul Pasha, Assistant Professor, Institute of Aeronautical Engineering from Department of IEEE, Hyderabad. So this is course about power system operation and control. So here today's topic is discussion about on IEEE standard parameters for basic excitation systems. How can we define for a particular synchronous machine? So what are the parameters associated and how they will influence the whole excitation system? These are the aspects we will discuss for this topic. So coming to the standard parameters of excitation system, the first case is digital excitation system. So what is this digital excitation system? We already gone through the whole excitation process earlier videos. We discussed how they will influence the power system operation. So coming to here, digital excitation system, usually we will treat it as a common nomenclature for describing an excitation system for a synchronous machine where some, if not all, of the functionality is implemented in a digital processor. So as a minimum case, the AVR control function would be expected to be implemented digitally in such a system. So AVR means here automatic voltage regulator. Automatic voltage regulator or controller. Automatic voltage regulator. So it is likely that the limiter functions and optionalities in VARs or PFs or PSS are the controls which are also implemented in the same digital based control system. That's why this can act towards the control of the voltage of the whole excitation system. Another parameter called discharge resistor. So here a resistor that is upon the interruption of excitation source current. When there is a interruption in the source current which will be connected across the field winding of the synchronous machine, or it may be connected to the exciter, this will be ready to limit the transiency in voltage. So what are transiency in voltages? So if you observe transiencies in voltages, that means this may be taken place. So this transiencies may expected in the voltages which will act as one of the interruption. These interruptions are mostly on the occurrence of the loads. So loads will fluctuate, due to which the response will be affected mostly. Response will be affected. So here what happens means, because of the presence of transiency voltage in the field circuit, and it has to hasten the decay of the field current of the whole machine. So here we are treating synchronous machine. So field winding of that particular synchronous machine or the exciter is ready to limit the transiency voltages which will be in the field circuit and will be to hasten the decay of the field current of the whole machine in the network. Next, discontinuous excitation control. So here control function that acts to rapidly changes in synchronous machine excitation to the level of different than the called for the by the voltage regulator and power system stabilizer for a period of time which is following a system fault or disturbance, then which will be treated with a discontinuous excitation control system. This discontinuous excitation may leads to the malfunctioning of the system parameters. So this is also to be known as discrete field forcing. Discrete field forcing is the one of the mechanism. Discrete field forcing is one of the mechanism, or transient excitation boosting. So these are the parameters which will mostly influence the whole system. And coming to the entire excitation control system, the feedback control system, that includes the synchronous machine and its excitation blocks. Excitation control system means here feedback block, that is including synchronous machine and its excitation system. These combinational aspects may be treated as whole excitation control system. So here the term is to differentiate the performance of the synchronous machine and excitation system in addition with the power system is from the excitation blocks are as individual in nature. That means they will be treated as isolated or individual in nature. So if you observe this one, here we are connecting various blocks like synchronous machine regulator, exciter, synchronous machine, power system components. So these are acting as connecting feedback path blocks. So here the excitation system is treated as the combination of synchronous machine regulator to the exciter case. This combination will be wholly treated as exciter system. And coming to the blocks of excitation system connecting to the synchronous machine is wholly treated as excitation control system. Means from this end to this end, this block will be the excitation control system. This is the whole representation of the block diagram of entire excitation system for a given synchronous machine. So coming to the excitation system, the equipment that is providing the field current for a synchronous machine, including all powers, regulating, controlling and protective elements. These all the blocks will to be known as excitation system blocks. So coming to the excitation system duty cycle, an initial operating condition and a subsequent sequence of events of specified duration to which the excitation system will be exposed. That should be treated to be the excitation system duty cycle. So here one thing we need to remind that the duty cycle usually involves a three-phase fault. So usually we will treat a duty cycle from the assumptions of these conditions of the fault tolerant value. So duty cycle may be treated from one instant to another instant. So here as the fault is specified under the duration that is located electrically close to the synchronous machine. That means its primary purpose is to specify the duty that excitation system components can withstand without incurring misoperation or damage to the whole system. That's why these are most prominent cases. So coming to the excitation system nominal responses, the rate of increase of the whole excitation system output voltage, which is determined from the excitation system voltage responsive curve divided by the rated field voltage. So how we treat nominal response means, nominal response is equals to the ratio, that means system voltage response divided by the rated field voltage. This ratio may be treated as one of the excitation system nominal response. So this rate, if maintained constant, that would develop the same voltage time area as obtained from the response over the first half second interval. So that should be unless a different time interval usually specified. So this is the curve representing how excitation system nominal response is generated. This is drawn in a time as in seconds versus exciter voltage. This combination may be treated as one of the excitation system nominal response. So this curve may be drawn from the point of OA and B, C, D. So here nominal response will be treated as one of the points of C to E. That means from this location to this location and A to O. So this whole response to this consideration may be treated as a nominal response difference by this AO to the OE case. That means from O to E case. So this point is treated as whole nominal response of the system, where OE is the 0.5 seconds time period, AO is the synchronous machine rated voltage. So these are the parameters usually treated for getting the excitation system nominal response. So excitation system output terminals are going to be treated. So the place of output from the equipment comprising the whole excitation system, these terminals may be identical with the field winding terminals usually. That means excitation system rated current is going to be treated. So the direct current at the excitation system output terminals that the excitation system can supply under defined conditions of operations. So during which the rated current is maintained as a constant in the whole excitation system, as the output terminals are connected in place of the output from the equipment, which are containing the whole excitation system with the terminals may be identical in nature with the given field winding cases. So here this current is at least the value required by the whole synchronous machine under the most demanding continuous operating conditions. So what are those means? Generally they will resulting from synchronous machine voltage, frequency and power factor variation. So these may give suitable operating points. So excitation system under rated voltage is treated here. So the direct voltage at the excitation system output terminals that the excitation system can provide when delivering whole excitation system rated current under rated continuous load conditions of the synchronous machine with its field winding under 75 degrees centigrade is one consideration for field windings designed to operate at a rated with a temperature that should be increasing from 60 degrees centigrade or less than that. Or we may treat under 100 degrees centigrade for field windings designed to operate at rating with a temperature rise which will be greater than 60 degrees centigrade. So these are the various parameter variations under various temperature cases, 75 and 100 degrees centigrade. So coming to excitation system stabilizer, a function that serves to modify the voltage regulator forward signal by either series or feedback compensation. This is ready to improve the dynamic performance of the whole excitation control system. That means excitation system voltage response time is increased. So here which will be treated in seconds for the excitation system voltage to attain 95% of the difference which will be between ceiling voltage and rated field voltage under specified condition. So this is in between ceiling voltage and in between the rated field voltage. Under rated field voltage, the excitation system voltage response is wholly considered about 95% of its final value. And coming to the exciter case, this is the device or equipment that will provide the field current for the excitation of a whole synchronous machine. That means fault current limiter is considered. So this is acting as a function that is ready to prevent the stator current from exceeding a preset value during steady state operation of the generator with a short circuit applied to its output terminals. So limiter will be acting as to limit the fault current. So this is by decreasing the excitation, and it is also known as line current limiter. This is also known as line current limiter. And one more thing is field current or voltage limiter. What is this field current or voltage limiter means? This is a control function that will act to prevent the field current or voltage from exceeding it to the preset value. So the field discharge coefficient of the circuit breaker may take in place. That means circuit breaker having main contacts for energizing and de-energizing the field of the synchronous machine or rotating exciter. So during which what happens means the discharge contacts for short circuiting the field through a discharge resistor that will be prior to the opening of the circuit breaker, main contacts are going to be taken place. So the discharge contacts also disconnects the field from the discharge resistor, which will be following the closing of the main contacts case. Next thing is field flashing. What is field flashing means? Momentary application of DC power to the field of a synchronous machine. That means for the purpose of building up terminal voltage, field flashing is going to be considered. So coming to field forcing parameter, this is a control action that will rapidly drives the field voltage of a synchronous machine in the positive or in the negative direction. Coming to field voltage or field current regulator, a regulator that functions mainly to serve the field voltage or field current at a predetermined value or suitable value cases. What about the field winding in the synchronous machine means? A winding on either the stationary or the rotating part of a synchronous machine. It may be stationary or rotating part of the synchronous machine, whose purpose is the production of the main electromagnetic field of the whole machine. Coming to field terminals or field winding terminals, here the place of the input to the field winding of the synchronous machine is to be treated as field winding terminals. If there are brushes and slip rings or collectors, these are considered to be part of the one of the field winding. Coming to freewheeling diode, this diode connected across the controlled bridge of a static excitation system. This is ready to provide a path for the whole field current to flow if the normal bridge path is not available. This is also to be known as flyback diode. Flyback diode. This will remove the whatever the contents available in the harmonics case. So this will may be treated as freewheeling diode. This is also known as flyback diode. So the ripple content present in the whole system can be removed or nullified by this one of the flyback diodes or freewheeling diodes exist in the whole system. High initial response. Why can we expect this high initial response means? An excitation system that is ready to attaining 95% of the difference, that is in between ceiling voltage and rated field voltage, in a time factor about 0.1 second or less under specified conditions. High initial response is going to be considered. Next, impedance case. What happens with the impedance case of the compensator means? Line drop compensator is used in between the lines. Reactive drop compensator is used in the same line existing case. And coming to large signal performance case, how the response is differentiated means the response of the excitation control system or excitation system or elements of an excitation system to the signals that are very large enough and that must be included in the analysis of the response to obtain realistic results. During this condition, large signal performance is going to be expected more. Line drop compensator. What is line drop compensator means? A function that usually modifies machine terminal voltage, that is to compensate for the impedance drop, that is to a fixed point external to the synchronous machine terminals. So here what happened with the line drop compensator means whatever the synchronous machine terminals which are supposed to be fixed at the point of external terminals, they will ready to compensate for the impedance drop. That means which will ready to nullifies or changes the machine terminal voltage and it will ready to compensate the line drop. And coming to load current compensator. What is load current compensator means? This is a function that will act to influence the voltage regulator action and ready to control the voltage at a point other than where synchronous machine voltage is going to be measured. During that conditions, load current compensator is mostly introduced. Some of the specific uses are there for reactive drop compensations. They will be reactive differential compensations, line drop compensation methods. They will be treated mostly to undergo the whole system parameters performance. Next control is a manual control approach. What is this manual control approach means? Usually in excitation system usage, what happens means manual control refers to the direct control by the human beings of the synchronous machine by the operator action. The operator will be there, he can ready to operate whole system. And here in manual control, it may include open or closed loop control of the exciter output. So, or it may means that does not directly control the synchronous machine output variables. So, coming to no load field current, the direct current in the field winding of the synchronous machine, they require to produce a rated voltage at no load and a rated speed current. So, this is going to be taken place under no load field current cases. So, like that manual control operation with a suitable no load field current is going to be treated to operate for the excitation of the whole synchronous machine. No load field voltage. What is this no load field voltage means? The voltage required across the terminals of the field winding of the synchronous machine, which will be under conditions of no load, rated speed, rated terminal voltage with the field winding at 25 degrees centigrade. During that, no load field voltage is going to be treated. Coming to null balance case, what happens with the null balance means, here in the null balance condition, a circuit or the action designed to match the output of the whole automatic voltage regulator and the manual control that is ready to minimize the transient upon transfer or regulator control action, this null balance is going to be treated. This will be mostly influencing the system parameters under no load field voltage cases. Over excitation limiter, that means OEL. So here it is a control function that will ready to limit the field current of the synchronous machine or excitation equipment that is ready to permissible the values with regard to the threshold overload voltage. That means some actions may be intermediate or time delayed here for the over excitation limiter control. So they also to be the maximum excitation limiter. That means permanent magnet generator is introduced, that is as PMG. So this is acting as an auxiliary synchronous machine. That means with the permanent magnetic field, they use it to supply the power requirements. So that is fixed to a portion of the excitation system. This is also known as permanent magnetic alternator. That is called PMA. One more thing about this excitation system is about pilot exciter. What is pilot exciter means? Equipment providing the source of field power, that is for the excitation of another excitation system. And the thing is potential source rectifier exciter. What happens here means an exciter whose energy is derived from a stationary AC potential source, and it may also converted to direct current by the rectifier's case. That means the exciter includes the power potential transformers and also power rectifiers, and that may be either non-controlled or controlled, including gate circuitry cases. So this is exclusively for input control elements. These are only suitable for only input control elements. They will be act as potential source rectifier circuits. So here the source of AC power may come from the machine terminals, or they from the stationary auxiliary bus systems, or from a separate winding with the synchronous machine. So here the source may be created like this. That means the source of excitation for the synchronous machine is drawn like this. This is the source of excitation. Source of excitation, which will be coming from the machine terminals. So here the machine terminals are connected. Machine terminals, or which may be treated from one of the stationary auxiliary bus. This is called as stationary auxiliary bus. Stationary auxiliary bus. So this system is connecting to the one of the winding part. This winding part will influence the synchronous machine, which may be connected to the system. This is the synchronous machine block. This is synchronous machine block. So likewise, source of excitation is starting to the machine terminals, or it may be to the stationary auxiliary bus. The bus may be connected in between the two lines. This is the existence of the bus. So these machine terminals are connecting to the stationary auxiliary bus. This is connecting to the winding of the machine. This is the winding of the synchronous machine. And this synchronous machine is coupled to the whole entire response of the system for a generation case. So likewise, we can act the source of AC power, which will be coming from one of the source system. That means machine terminals are from a stationary auxiliary bus or a separate wind. This may be wholly treated for the entire excitation of the synchronous machine. Likewise, this will be ready to function for the machine under various excitation cases. These excitations will influence the system parameters. Under field winding cases, they will be respectively producing the field currents at a suitable range of the machine parameters. So these are some of the references whichever I have treated, and this gives the more information about video lectures and some PDF analysis. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.